Hello everyone. So today we will try to understand the graph of U versus V for the three mirrors, that is plane mirrors, concave mirror and convex mirror. Let's start with and then we will also see the graph in a online calculator, graphical calculator. How does it really look like? Okay. So we'll start with the plane mirror. So plane mirror, if you remember in the beginning I have taught you that for plane mirror image distance is equals to object distance. That means if this is the object distance, this is the image distance. So only thing sign convention applied here is u equals to minus v, or v equals to minus u, because this side is negative, this side is plus. So if we plot the u versus v graph, so if we plot the u versus v graph, let's say plot this graph. The x-axis is the u, this is minus u, this is v, this is plus v. You will see the graph to be like this. So the angle between this is 135 degree. This angle will be 135 degree. V equal to minus u. That's it. This is the u versus v graph for plane mirror. Now let us see u versus v graph for concave mirror as well as convex mirror. We will learn two kind of graphs here. What is u versus v and what is 1 by u versus 1 by v. Now there is one practice. There are a few practicals in this course in which you have to find the focal length of a concave mirror uh, using u versus v graph or 1 by u versus 1 by v graph. So actually through that practical we want to learn the graph. So if I plot the graph, so in case of concave mirror, if you see this is a concave mirror, this is our principal axis, so now if I plot the graph, so the graph for this is u, this is v. The graph for the concave mirror is a rectangular hyperbola. So this minus u, this is v, this is, sorry. So it's a rectangular hyperbola. So by rectangular hyperbola, what do I mean? So it will go like this. You will be learning, I hope you have learned in class 11 what a rectangular, this is the rectangular hyperbola. This is in the third quadrant. Its asymptotes will be passing through its asymptotes. Let me use some other color. His asymptotes will be passing through this point, which is the focal length. Fine. And if you draw a 45-degree line from the center, it will intersect at this point. The coordinate of this point is minus 2f minus 2f. Understand? We're going to use this principle in practical to find the focal length of concave mirror. Clear? So for concave mirror, why it is in the third quadrant? Because in this case u is, sign convention, u is negative, v is also negative. So as they are negative, so it's in the third quadrant. Now guess for convex mirror. In case of, what will it in case of convex mirror? So in case of convex mirror, this is our convex mirror, right? In this case, definitely V is positive, right? And U is negative, and focal length also is positive. So it should be in the which quadrant? I hope by now you have guessed it, or you can think in which way, in which quadrant it would be. So let me draw the graph once again, or I can show it here also. So if I draw this curve for convex mirror, it is in the first quadrant. Sorry, using this, it is in the first quadrant. Let me use a separate color to identify that this is okay. It is blue. So this is the rectangular hyperbola U versus V graph for convex mirror. Understand? So if I draw the asymptote here now, if I draw the asymptote, it will pass somewhere here. This point is F. Remember that. This is the focal length. And if I again draw a 45-degree line, it intersects at this point. The coordinate of this point would be 2F, the radius of curvature, radius of curvature. Understand? So this is the U versus V graph for spherical concave mirror and convex mirror. Understand? Now let us see for the this 1 by U versus 1 by V graph. So this one is U versus V, U versus V. So let us see for 1 by U versus 1 by V. To draw 1 by U versus 1 by V, I again draw the graph here. Is very simple. This is 1 by U and this is 1 by V. You can see from the equation 1 by F is equals to 1 by U plus 1 by V, right? If this quantity is 0, 1 by F is equals to 1 by U, right? So this is my first point. This is my first point. And if U is 0, 1 by F would be equals to V. So in that case, this is the focal length. So the curve is this one, like this, straight. This is for if positive, so that means this must be convex mirror, and the opposite, this is for the concave mirror. Understand? This is minus 1 by U, this point is minus 1 by V. So you can see this is 0 means 1 by F is equals to plus minus 1 by U. If it is plus, it's convex. If it is minus, or if 1 by V equals to 0 or 1 by U equals to 0, then 1 by F is equals to 1 by V, right? So this is the graph. Now we will see this in a graphical calculator. I'll plot the equation 1 by F equals to 1 by U plus 1 by V and try to see all this what we are learning theoretically, is it practically true or not. Okay, let's see. Hello everyone. So now we will use a graphical calculator to visualize U versus V and 1 by U versus 1 by V graph. So let's start with the plane mirror. In case of plane mirror, the equation relating the object distance and image distance is V. Sorry, I will denote V by Y and U by X. So Y equal to minus X. there is the line. So I have taught you earlier that the slope of this is this angle would be 135 degree. So you can easily find out the slope from there. If not mistaking, the slope will be minus 1. The slope of this curve is -1. Next is, now we will see in case of mirror equation how is the curve. So 1 by f equal to 1 by x plus 1 by y. I will define x. Can you see the graph on the right side? So let's say I'm using a mirror whose focal length is 10 cm. So this is the focal length 10. Let me zoom out a little bit. There is the curve. We are not interested in this one. We are interested only on the first quadrant, the curve. And I told you the asymptote will pass through the focal length. So you have to draw the focal length asymptotes. What are you going to do? X equal to 10. There is the one, and y equals to also 10. This is the point. You see, this is our focal length. Now radius of curvature is this point. Can you notice there? The coordinate of this point is minus 2f, sorry, plus 2f plus 2f. So 10 centimeter with the focal length, 2 into 10 is 20. So 10 is the radius of curvature is there. This is what you are going to use. This concept you are going to use in case of that practical to find the focal length of a concave mirror from the graph u versus v and u versus v. So in case of u versus v, the graph will be a rectangular hyperbola. This is what you see here. And then you draw a line from here. You carry on the experiment. After carry out the experiment, you get some data points. When you plot the data points, you should get the graph like this. Understand? Note properly. Here, as u gradually increases, v is very high, it is coming down, and then as u is increasing, v since decreases. Okay, they are symmetrical about this point. About the diagonal, this point will be symmetrical. These points will be symmetrical. You see 60, and what value of here? It will be exactly same thing. Yeah, the symmetrical points. Now, to find the focal length, you see it will be 20, comma 20. This is the point. This is the radius of curvature. Okay, and this is the focal length. Right? The focal length it would be how much? 10, comma 10. So imagine you perform the experiment, you got data points, you plot it, then from here you need to just draw a line y equals to x line, a 45-degree line. It will intersect these 2 points. This point being the radius of curvature and this point being the focal length. Understand? Now we will see this is for which kind of mirror? This is for the convex mirror because f is positive. Now what about the concave mirror? You can see the graph from here. What about the concave? In case of concave, I will remove this. In case of concave, let's focal length will be minus. There you see it is in the third quadrant. Again same way. Now the asymptote will pass through x equals to minus 10, y equals to minus 10. Here is it, and the point will be minus 20, minus 20. This is it. This is the radius of curvature. Understand? And to plot the 1 by u versus 1 by v is very simple. This is actually a straight line. I will show you. Let's say u equals to, because you see 1 by f is equals to 1 by v when 1 by u equals to 0. That means f is equals to u only. So f is equals to u means, let's say u equals to 10. That means focal length is equals to 10. This is our first point. Sorry, not u, I have to use the x here. X, there is it. And y equals to 10. I'm interested in these 2 points. Okay, let us show in another way. I will use 2 points here. 10 comma 0 is the point, and again I plot another point 0 comma 10, the second point, right? Now if I join them, if you join these two, you will see okay, these are individual points. Now okay, no problem, these are individual points, no problem. So imagine that you are drawing one line from here. So this line is giving me the 1 by u versus 1 by v curve. You can, in the graph, you can define the axis levels like this. This is 1 by u, this is 1 by v. In case of, this is for the convex mirror, and in case of convex mirror the 2 points will be on the third quadrant. Thank you.